Welcome back, second grade. Today is Friday, June 5th, 2020, and we are going to jump into our next lesson about angles. Please make sure you have a piece of paper and something to write with so that you can do the work. So, yesterday we learned about a right angle, and as you can see here, a little reminder, a right angle is when the space between two lines that connect make a perfect square corner. But we're going to be talking about two other types of angles. And those types of angles are when you don't have that perfect square corner. One of them is called a greater than angle, or a greater than a right angle. An angle that is a greater than a right angle is when the space between the two lines that connect is wider or bigger than a right angle. As you get older, you're going to start referring to these angles as obtuse angles. Obtuse angles is a word for angles that are bigger than or greater than a right angle. And now the other type of angle is an angle that is smaller than a right angle or less than a right angle. And it says an angle that is less than a right angle is when the space between two lines that connect is narrower or thinner than a right angle. And here you have a picture here. As you get older, you're going to learn that the name for angles that are less than a right angle are acute angles. But we like to talk about them as in terms of less than or greater than. So I'm going to zoom out here so you have this little visual tool to help you answer today's problem-solving task. So today's problem-solving task says, what type of angle is each numbered angle below? So your job is to write down if angle 1, 2, 3, or 4, if they are a right angle, a greater than angle, or a less than angle. So go ahead and pause the video and write down what type of angle those are. Okay, hopefully you've had time to answer these questions, and now we can jump into going over this together. This angle stuff can be super tricky, so if you're confused at all, don't worry, definitely reach out to your teacher and they can help explain it so that it makes more sense. Let's start here with angle 1. So angle 1 represents this space, right, between these two lines that connect here at the point. I'm going to zoom in. Angle 1, when I look here, I have a perfectly horizontal line on the bottom. And if I'm going to be like the way that I like to solve these problems is I like to first see and check to see if it's a right angle. So that's what I'm doing here. I can see that I have a perfectly horizontal line. And then if this was a perfectly vertical line, it would have to connect to this dotted line. Does it connect to this dotted line? No. But in fact, it's a little bit smaller. So because it's smaller than a right angle, we would call angle 1 a less than right angle, or as you get older, an acute angle. Now let's look at angle number 2, which happens to be up here, right across from it. Angle 2 has I'm going to check to see if it's a right angle first. Has a perfectly horizontal line at the top, and then does it have a perfectly vertical line? Well, a perfectly vertical line would go like this. Does it connect to my dotted line? No. So because of that, it is not going to be a right angle. It's actually smaller. So angle number 2 is less than as well. It's an acute angle. It's less than a right angle. Now let's go to number 3, which happens to be up here. Angle number 3 is this space right here between these two lines that connect here at the point. Angle number 3 has a perfectly straight horizontal line at the top. If it has a perfectly straight vertical line, it would look like this. It doesn't connect to my dotted lines, and it's not smaller. If it was smaller, it would be closer to the horizontal line. It's actually bigger. It goes out. So that means that angle 3 is a greater than right angle. As you get older, you'll call these obtuse angles. And the last one, angle number 4. Angle number 4. Let's check to see if it's a right angle. So I have a perfectly horizontal line here. and then a perfectly vertical line would look like this. Does it connect to my dotted line? No. So it's actually a little bit wider, and because it's a little bit wider, I'm going to call this a greater than angle. So that means that this shape, which is a parallelogram, quadrilateral with two sets of parallel sides, has two angles that are greater than right angles and two angles that are less than right angles. It actually has 0 right angles. So today we're going to be looking at shapes, and we're going to be figuring out what type of angles these shapes have. So let's get started. Awesome. I am going to skip number 1, and we are just going to do 1 together. And then I'm going to have you try these 2 by yourself, because the more practice you do on your own, I feel like the more this is going to stick for you. So here's number 2, and this is the only one we're going to do together. So number 2, I can tell right now, is a triangle, which means it has 1, 2, 3 angles. 3 angles, 3 sides, 3 vertices. So let's take a look at this angle up here and try to figure out what type of angle it is. So I have a perfectly straight line at the top, of a straight horizontal line. I'd like to figure out if it's a right angle first, and that will help me determine what type of angle it is. So I have your perfect straight horizontal line, and then if I draw my perfect straight vertical line down, I can see that the actual line of the shape does not match up to where it would if it was a right angle. It's actually narrower or thinner, which means it's a less than. So I'm going to write less than here. So I know that this angle represents a less than right angle. Now I'm going to go over here. I can see that this angle has a perfectly straight horizontal line at the top, and if it had a perfectly straight vertical line, it would look like this. Does it connect to my dotted lines? Absolutely. So this is actually a right angle, which is a perfectly square corner. So I'm going to write right. And then down here, I need to figure out this one. So this line right here is a perfectly straight vertical line. And if it was a right angle, it would have a perfectly straight, it would connect to a perfectly straight horizontal line. But as you can see, the line of the shape does not connect there. It's thinner, and because it's thinner or narrower, it's actually a less than. So now we can record what we figured out. Greater than right angles. How many do they have? 0. This shape has 2 angles that are less than right angles, and just 1 angle that is a right angle. You're going to go through the same procedure with these next 2 shapes. And for these next 2 shapes, actually, you know what? You're not going to do the shape. And you're not going to do the shape because it's the same shape that we did in our problem solving task. Sorry about that. Which means you are just going to do the same process for this shape here. Before you go off and pause the video, I want to just make sure you know that this shape has 1, 2, 3, 4, 5, 6 total angles, because it has 6 total sides and 6 total vertices. So that means your numbers here should add up to 6. Go ahead, you can even draw this yourself, but definitely go ahead and try to figure out if this how many right angles, greater than and less than angles this shape has. Pause the video and go ahead. Excuse me. All right. Hopefully you've had a chance to answer this. I know angle stuff can be super, super tricky. I hope this is feeling a little bit more manageable and a little bit easier than at least yesterday's lesson. But let's go over it. So we have to figure out and determine which angles are right angles. So I'm going to start up here. And we actually have to figure out not just if they're right angles, but what type of angle they are. I always like to start by seeing, is this angle a right angle or not? So that means a perfectly straight horizontal line that connects to a perfectly straight vertical line. This, unfortunately, is bigger than a right angle, so I'm going to put a G for greater than. Over here, it has a perfectly straight horizontal line, and it should connect to a perfectly straight vertical line if it's a right angle. As you can see, it doesn't. It's bigger, it's wider, so this is also a greater than. Over here, I'm going to just turn my paper a little bit so that I have one of my sides of this where these lines meet. One of my lines here is perfectly straight. As you can see, this is perfectly straight. And if it was and it should be a right angle if it matches up to a perfectly straight horizontal line. As you can see, it doesn't. It's actually wider than that. So this would be also a greater than angle. Here, I have a perfectly straight horizontal line. If this is a right angle, it should match up to a perfectly straight vertical line. Does not connect to my dotted lines. It's actually wider, so that means it's a greater than angle. Over here, I have a perfectly straight horizontal line. If this is a right angle, it would match up to a perfectly straight vertical line. It doesn't. It's wider, so that means it's a greater than angle. And the same thing here. Here's a straight vertical line down, and if this was going to be a right angle, it would match up to a perfectly straight horizontal line. Unfortunately, it doesn't. It's wider, so this is also a greater than a right angle. So this hexagon, remember, six-sided shape is a hexagon, has 6 greater than right angles, 0 that are less than, and 0 that are actually right angles. I know this stuff is tricky, but right now I want you to take some time, and I want you to work on your exit ticket where you'll be looking more at different shapes and angles and trying to determine if they are larger, they're greater than a right angle, smaller than a right angle, or less than, and right angles. Reach out to your teachers if any of this is confusing. I hope you have a fantastic weekend. Next week when we come back with a video, we're going to start to talk about a shape called a rhombus. Awesome. Take care.